Hello everyone, my name is Akib and I'm really excited to be part of this year's Advent of Cyber. Today we are going to look at day 18 task. So far we have covered a lot of very interesting topics. Each day has brought some interesting learning objectives and today is another day and today we are going to look at threat detection and Sigma. So before starting, please start the lab. It will take around 3 to 5 minutes to start. So what's the story? As we already know that compromise has been confirmed within the best festival company infrastructure and tests have been conducted in the last couple of weeks. However, Center's SOC team wonders if there are methodologies that would help them perform threat detection faster by analyzing the logs they collect. Elf McSkiddy is aware of Sigma rules and has tasked you to learn more and experiment with threat detection rules. So in this task, we will be learning about Sigma rules. What Sigma rules are? If we look at Yara rule, Yara is another threat detection tool that looks for the suspicious patterns within the file, and in the same way, Snort is a threat detection tool which looks at the suspicious patterns on network traffic. And in the same way, Sigma is a threat detection tool that which is a generic rule that looks for suspicious patterns within the event logs. Okay, so this is something that we will be covering shortly. Cyber threats and the criminals have advanced tactics to ensure that they steal information and create havoc. As we have already seen through previous days, there are many ways in which this can be done. There are no ways for security teams to prepare their defenses and identify these threats. What could be evident is that most of the blue team activities will require proactive approach to analyzing different logs, malware, and network traffic. This brings about practice of threat detection. Threat detection involves proactively pursuing and analyzing abnormal activity within the ecosystem to identify malicious signs of compromise or intrusion within the network. Attack scenario. So we have three attack scenarios that we will be covering in this task. Elf McBlue obtains logs and information concerning the attack on the Blue Festival Company by the bandit Yeti, which is the bad guy we have seen so far. Through the previous analysis of various analysis of the previous days, it was clear that the logs pointed to a likely attack chain that the adversary may have followed and can be mapped to a unified kill chain. This is the topic that we covered in the day one task. Among the known phases of unified kill chain that were observed include the following: persistence, discovery, and execution. So we know that adversaries, when they compromise a machine, they try to create persistence through different means. The adversaries established persistence by creating a local user account that could use during the attack. Discovery, we know there are many ways attackers use to create discovery within the compromised machine. The adversaries sought to gather information about their target by running commands to learn about the processes and the software on the center's devices to search for potential vulnerabilities. Third is execution. Scheduled jobs were created to provide an initial means of executing malicious code. This may also provide them with persistence or to be a part of elevating their privileges. Okay. The attack chain report included indicator of compromise. So this is the attack chain report that has given to us, and it includes indicator of compromise and necessary detection parameters. These are the necessary detection parameters that we need to look at. Additionally, the attack techniques have been linked to MITRE framework for further reading. So we can look at these attack techniques as well. So just to give you an example, when a user account is created on a machine, event ID 4720 is generated. So an event is generated. Let me give you an example. So I am opening up my Windows 10 VM. And what I'm going to do is I'm going to first open CMD in with admin privileges. At the same time, I will search for event viewer. So event viewer is a place where Microsoft stores all the events of the activities that we perform. Okay. So as we know, each activity that is performed within on a machine generates certain sort of events, and those events contain all the information about that particular activity. So just to give you an idea, for example, these are some events that are generated, and if we look at this event ID tab, we see that each event is associated with each event is associated with a unique event ID. So, for example, 4624 is the event ID that represents any time a user account logs in to to the machine, this particular event ID will be generated 4624. So what I'm going to do is I'm going to create an account. This is something that we just to see how things are reflected in the event logs. What I'm going to do is I am going to create an account. Let's say an adversary got access to this particular machine and he wants to create an account. There are many ways the adversary or we can create an account. What I'm going to use is I'm going to run command user add, and let's say attacker was able to run this command and create a backdoor account. So it is saying that the command successfully completed. Okay, so if we look at over here and see how this particular activity was reflected in the event logs, let me refresh that. And if we okay, so these are the events that were generated for this particular activity. So if we look at this, we have the event ID 4624. When we double click on this, it says that a user account was created, and it has all the information that is required for us to create a detection rule on. So it has multiple fields and their respective values. So the important thing is this event ID, and log name is security. There are many subcategories within the event logs: security, setup, system, forwarded events, and application. So we are at security. So to create a detection rule on this thing, we need the event ID, and we need to have this as security. These are the two fields that we require. Okay, so let's move on. And for the software discovery, we are looking at sysmon log source. We know that different log sources generate different kind of logs. So over here we will be looking at sysmon. So again, what I'm going to do is I'm going to copy this command and replicate how this thing is represented in the event logs. Okay, let me close that. Let me copy again. So before clicking, let me go to open the sysmon logs. So here it is. So we have sysmon logs. Okay, what I'm going to do, and let me give you an example. Okay, sysmon is a log source that collects different events, and it also associates different events with different particular event ID. For example, if we see event ID 3, it means that a process has initiated a network connection. For event ID 1, it represents a process creation. Whenever we execute a program, event ID 1 will be generated. And similarly, if there is some modifications to the registry, event ID 12, 13, 14 will be generated, and so on. So what I'm going to do is I'm going to go to my lab again, and click on this particular command and see how this particular command is reflected. So what this command is doing is this command is using rec.exe to query this particular registry key to check the service version of Internet Explorer. Okay, so now the adversary may try to figure out that okay, so Internet Explorer version is 11.789, and maybe there's a vulnerability that I can exploit. So this is one of the reasons that adversaries try to check for the versions of the softwares installed on the compromised machine. Okay, so how this particular activity is reflected in the event logs. Let me refresh this, and so if we look over here, so we ran this particular command. Okay, so the event ID 1 is generated for this particular process. We have the command line that contains the command that we ran. We have the process name that was executed, and some hash values, etc., which can be also important for us. And we open cmd and run that command, and from which machine, which user executed this particular command. So these are the information that is provided with it, available within that event log. Okay, let's try the third example. Okay, schedule task. This is okay. Let's try this. Okay, schedule task. We know why the attackers may try to schedule a task. So again, these are the indicators of compromises. This information can be found within the event. So what I'm going to do is I'm going to run this command. Let me copy again and paste it over here. And let me execute this command and see how this particular activity is reflected in the event logs. So I'm gonna refresh again, and let's see, this is the event log. If I click on that, it has all the information that is required to us, right? So we have the command line, we have the application that was run, the image field, it contains the application that was run, the event ID, right? So all the activities that we perform is reflected in the event logs. This is important. So this was it. Okay, so now it's time for practical work. What we need is, for example, if you have started the lab, let me give you an overview of how we are going to use the lab. So this is the lab, and it has a text editor, and this is a Sigma rule template where we will be editing our Sigma rules, and these are the attack chain um, details that we need to create rules on, right? So we need to create an activity for suspicious account creation, and what we are going to do is we will click here, and then we will create a rule on, and once we create a rule, we can check that by clicking here, and it will say if we have made certain mistakes, so it will highlight over here, and then if we have written a correct rule, and then it will show us a flag. Okay, so before diving into Sigma, let's understand what Sigma is, right? Sigma is an open source generic signature language developed by these guys to describe log events in a structured format. So we have looked at the event logs, and now we are going to use Sigma to create detection rules. And it is the format is YAML, and these are a couple of characteristics of YAML. For example, it is case sensitive. The extension is .yml, and the spaces are used for indentation. If we need to use comment something, we can use this. Um, we have to use colon for key value pair, just like this. Um, we have to use colon for key value pair, and so on. And these are a couple of other details that you can read. So let's jump into the rule syntax thing. It has a particular rule syntax that we need to follow. For example, the first part has no, is known as metadata, which includes title, that we can name anything. For example, we can name here as, for example, we can add anything. For the ID, we can include some ID. For this, for the status, we have four options. We can, if the rule is stable, we can add stable. And if we are experimenting on the rule and we are not sure about that, we can use it as exceptional. If, let's say, the rule is no more supported, so we can add unsupported. So let's say I'm going to add exceptional, experimental over here, and remove all the remaining description. I can add, let's say, this rule will detect when an account is created. For the author, you can use any name, and let's say, and next. Okay, for the description, we can add the description. This is the example. You can copy paste same thing in the lab as well. Detects the creation of local account or local user account on the machine. So, okay. For the log source, we know that different log sources generate different logs. So we need to mention what kind of log source we are collecting logs from. So it has four optional attributes like product, category, service, definition. For example, if we have a Windows product, we can use that. For service, we are using security. And over here, let's say, let me remove this. And for the product, we are using Windows, so I'll remove all the remaining. And for the service, we are using security. We can leave category as it is. And for the detection, this is important thing. The detection has two main parts: selection and the condition. Let's do it over here. Detection, a required field in the detection rule describes the parameters of the malicious activity we need an alert on. This is very important. What fields we need to create a detection on? We will be adding the value in front of that. The parameters are divided into two main parts. The search identifier, what kind of value that we are trying to search. Um, Search identifiers are the field and the values that detection should search for. This is important. And the second thing is the condition expression. So we can use different conditions on that. For example, we can use and, or other logical operations. Okay. So let's use, it's saying that as, let's create a rule first. For example, we can also use transformational modifiers. We can use pipe to create different. Let's say we have multiple values in the command line, and we can add include all to include all the information, or to find all the information in that this particular field. Let's figure this thing out. Okay, so I'm going to look for. We are creating a rule to search for any event that whenever a user account is created. So we know that when account user account is created, event ID 4720 is generated. So what we are going to do is we are going to add this particular field, event. ID 4720. So what we have two information that are required: service and event ID. And we can add false positive if there's a chance of false positive, or we can, for example, the level we can give is low. Click on the run button and see we have successfully created a sigma rule to detect this particular activity. Okay, so let's answer. This is the flag. Yes, we have the right answer. And for the from the challenge one log, what user account was created? So to see that, click on view log. It will be displayed when you have the right answer. So what user account was created? So we can look at this particular account was created. Copy and paste it over here. Yes, we have the right answer. Great. So this is how Sigma rule works. So we have another example. Uh, Now we are going to create a rule for software discovery. For the software discovery, we know that we have seen that whenever a user runs this particular command, okay, this thing can change in the logs. Maybe there's another software that the adversary is trying to run. So we need to we cannot add this particular value in our search. So we need to add the all the remaining information. So for the category, let's create. I'm not going to add the information again. Again, you can add if you want. For the log source, we are using Windows. For the service, as we know that we are now looking at sysmon, so we have to add sysmon. And for the category, as we are looking at the process creation activity, we can use process creation. Excellent. So for the selection field, what else is remaining? Event ID. Event ID, we know that event ID was 1. If let's say let's check if our rule is correct. When we click on this, it says that there are some fields that are missing. So we have to add image. So as we can, for the image we can add all the information, but again maybe the paths can be changed. The adversary has copied this information from on some other place and running that, so we cannot add this to avoid any false positive. So we have to include this thing. How? Let's find out. So image, we can use ends with this. So okay, let's run again, and again we are missing another field. Command line. Okay, so for the command line, we can add all the information, or we can select some information that we know will remain constant. For example, red, query, these information will be constant. So let's add that. Contains all. So we have to include all the information that we think should be included, will be available in the event log. So query and software version. As we also found that in the event logs that this information was available. Let's click here and see if our rule is correct. Excellent. So we have solved another, we have created another log and another rule to detect this particular activity. Let me copy that and place it over here and see we have the right answer. What was the user's path in the challenge 2 log file? Okay, so in the log file, we have to look at the user path. Let's check. Excellent, we have the right answer. So this is getting interesting. Again, this particular activity generates the event logs, and within that event logs, these are the information values that are important to us. So we are again going to create a rule for schedule task creation. So every time schedule task is created, we have to look at the particular information. For the product, we are using Windows, and for service, as we are looking at sysmon logs, okay, we are again looking at process creation, and for detection, what kind of values are important to us. So this is again the same thing that we have looked at over here, right? There are a lot of information that are available, but those information are not constant. For example, the parent user cannot is not constant because it's obvious that if similar command is run on another machine, this will be changed, the time will be changed, so we cannot use those particular information. We only have to pick those fields that we think are will remain constant. So for the selection, let's add event id, which is 1. And what else? For the image, we have added category, we have added event id for the image, and again image ends with, we can add whole image path, but that may avoid, we have to avoid that as well. We can use that. Okay, so the other contains all. So this will perform AND operation on all the fields. So if any particular value is missing, it will not detect. So we have to include. Let's say because we are when we run this command, the command can be changed on login. This can also change this, the name of the task can also be changed. So these two values, I think, are enough for us to create rule on. Let's see. Let me click that. It says the rule is too generic. Okay, excellent. So we have solved this challenge as well. So let me copy that and answer. Excellent. So what is the MD5 hash associated with the challenge 3 logs? Let me look at the view log, and what is the MD5 hash associated with the challenge? So let me copy that. Excellent. And if you like detection, there are some interesting rooms on detection engineering, which is Yara. You can look at Sigma Snort as well. And I hope this was informative for you. Before closing, we have there's a reference to. So what is the logical next step after creating a detection rule in Sigma? Sigma is a generic rule. This is something that we have learned. There are a couple of command line tools that we can use to convert this Sigma rule into any security monitoring tool that we are using. Let's say, let me give you an example. Either you can use command line tools, or we can use encoder.io. So let's say we have created this particular rule. Let me copy that, and I'm going to convert this into any theme solution or the EDR that I require. For example, in my network, we are using Radar. So this particular rule we can convert this into Kirudar search query or Splunk query. Let's say we have Splunk, we can convert this into Splunk, or let's say if we are using another, for example, Carbon Black EDR, if we are using, we can convert this particular log rule into any search query of any EDR or the monitoring tool. That's why this rule is very powerful. So that's it. I hope you learned something new. See you in the next task. Thank you so much.